we're going to begin our unit on exponents. This is unit 6, and this is going to be lesson 1. In this lesson, we are going to be reviewing the exponent rules that we've already learned, and in the next lesson, we will be adding on 2 more exponent rules. So what I wanted to do for you is I wrote these out for you so that you could keep them in one spot. Multiplying exponents with the same base. If you recall, the rule is to keep the base and add the exponents. So underneath here, I'm going to give you one example. That would look like something like this. If you're multiplying 2 exponents, they have the same base. Remember, the base is the number on the bottom. We keep the base, so the base is x, and then we add the exponents. So 2 plus 3. So that would give me x to the 5th power. The second rule that we learned was dividing exponents. So if we're dividing exponents with the same base, we keep the base and subtract the exponents. So I will give you another example. Let's do x to the 6th divided by x to the 4th. Again, the base does have to be the same. So these are 2 x's. We keep that base, which is x, and we subtract the exponents. So this would be 6 minus 4. So my answer would be x to the 2nd power. Okay, and the third rule that we learned was the power to a power rule, which is where you keep the base and multiply the exponents. So in this example, let's say we have x squared raised to the, 4th power. Okay, in this case, if it helps you to remember, there's parentheses. When we see parentheses, we generally multiply. So we keep the base and we multiply the exponent. So it's 2 times 4. So that's x to the 8th power. Okay, that's just a quick review for you. So in beginning the lesson, we're not going to do all of this, okay? But we are going to go through a little bit. There's a lot of situations in science, engineering, and other fields where a process is governed by repeatedly multiplying or dividing the same quantity. So we've already learned that repeated multiplication and division can both be represented by exponents. So for this exercise, all we're doing is just reviewing. It's just reviewing. Okay, so for part A, we're going to write 6 to the 3rd power as an extended product, but we're not evaluating it. Okay, so 6 to the 3rd means that you're multiplying 6 by itself 3 times. So 1, 2, 3. Right? Another review is when we're dealing with exponents, we're going to find f of -1 here, which means we're plugging in -1 for x. So this is 2 times -1 to the 3rd power plus 3. You can definitely plug that into your calculator, but this will be 2 times -1 plus 7. -1 to the 3rd power is -1 times -1 times -1, which gives me -1. And then this would give me -2 plus 7. So f of -1 would be 5. Okay. If x to the 3rd times x to the 5th is written in the form of x to the n, what is the value of n? So what that means is just use your exponent rules. X to the 3rd times x to the 5th. What did we just say? We're multiplying 2 exponents with the same base. So we would keep the base and add the exponents. So that would be x to the 8th power. So when they're asking for the value of n, that means that it would be 8. N would be 8. Okay. And then quickly, 5x to the 3rd raised to the 2nd power. They want us to write it in this format, which just means basically just use the exponent rules here. So the one thing that we have to remember was if we have this 2 on the outside, it has to be applied to the coefficient as well. So this is like 5 squared times x to the 3rd squared. All I'm doing is squaring each of these. They're 2 separate things. They both have to be raised to the 2nd power. So that'll be 25. And then the rule here is keep the base and multiply x to the 6th power. Okay, they're saying this coefficient is a, which is 25, and the exponent is the b, so that'll be 6. So if they want to know a plus b, that just means will be 25 plus 6. It's just like a fancy schmancy question, which would be 31. I'll put that in parentheses because you don't really need to know how to do that. So for f, we're going to rewrite this as an equivalent expression in simplest exponential form. So all that means is just to simplify it. So I'm going to just rewrite this. 3x squared squared times 2x to the 5th cubed. So this is really just review. I know it looks like it's not, but so each one of these you're going to deal with it one at a time. When you're raising something to a power, you have to include the coefficient. So what I did when we first learned this was I broke it up. I did this like 3 times x squared. So I did 3 squared separately, and then I did the x squared also raised to the 2nd power, like that, okay? And now I have this one, same thing. This whole thing is being raised to the 3rd power, so I have to raise the 2 to the 3rd power. And then I'm going to do the x to the 5th to the 3rd power. I'm just breaking it up, that's all. Okay, so now I just do it piece by piece. So 3 squared, that's 9. X to the 2nd raised to the 2nd power. We keep the base and multiply the exponents. That's x to the 4th power. Times 2 to the 3rd power is 8. Again, you can always use your calculators for this. And then this is the power to a power rule. Again, I keep the base and multiply the exponents. So that's x to the 5 times 3, which is 15th. Now this is still not in simplest form because I now have 2 terms that have the same base, so I can use my multiplication rule. So I'm just going to show you what I do. I use the commutative property to put the 2 coefficients together and the variables together. So I'm just going to do 9 times 8 in the front and then take my 2 exponents. So x to the 4th times x to the 15th. You can skip this step if you want, as long as you know that you can multiply the 9 and the 8 together. Okay, and 9 times 8 gives me 72 times, now I have two exponents with the same base and I'm multiplying. So the rule for that is keep the base, which is x, and add the exponents. So 4 plus 15 would be 19. So this is 72 x to the 19th. Okay, so we took this monstrosity and turned it into this nice little thing. Okay. So that was a review. I know it was tricky, but it was actually a review. What we're going to talk about today is simplifying expressions where there's division involved, okay? All of these where they're asking you to write it as a product where 1 is equal to 1, we're not gonna do those, okay? Not for this lesson. So I'm just going to show you how to simplify. So what we're going to do is we're going to take the original, so 2x to the 6th power over 4x squared. And what I'm going to have you do is I'm going to have you break it up by the like terms. So that means I'm going to have you do the coefficients and the variables, 2 separate fractions like this. So it's 2 over 4 times x to the 6th over x squared. Basically all I'm doing is breaking these up. And then I can handle it one by one. Okay, so 2/4 is equivalent to 1/2. Remember to use your calculator. And then x to the 6th divided by x squared. You keep your base and subtract your exponents. 6 minus 2 is 4. So 1/2 x to the 4th would be this one simplified. Okay, let's look at another one. Okay. So sorry. Okay, so first looking at an easy base of just 5. We remember that we keep our base and we subtract our exponents. 7 minus 3 would be 5 to the 4th, right? This is basically just a quick review. Okay, this one, same thing. We're keeping our base and we're subtracting our exponents. So 4 minus 10 would give me -6. And now this one is where we're going to do what I told you. We're going to break it up by the like terms. So let me just rewrite this. This is x to the 4th, y to the 8th, over x, y to the 10th. don't be discouraged looking at this, okay? What we're gonna do is we're gonna break it up by the like terms, just like I did before. So I'm gonna write it with the x's alone and the y's alone. So the x to the 4th over x times y to the 8th over y to the 10th. Okay, and then I'm just gonna evaluate them separately. Okay, so we're gonna use our division rule, which is keep the base and subtract the exponents. Remember, if there's nothing there, this was so skinny you can't see it 1. So this will be x to the 4 minus 1, which is 3. So that's x to the 3rd. Times, and now y, I'm keeping my base and subtracting my exponents. 8 minus 10 is negative 2. So this gives me x cubed y to the negative 2nd power. And in tomorrow's lesson, we're going to learn what to do with this negative. But for now, you're going to keep it just the way it is. Okay? All right, let's take a peek at the slightly more complicated ones, and then you will be ready to practice. So what I'm going to do is I'm going to do A, and then you're going, actually, I guess I'll do B because it's more tricky. I'll do B, and then you can do A on your own. Okay, so first things first, when you have something like this, you're going to simplify the top and the bottom separately as much as you can before you break them up. So I cannot break these up by the like terms yet, and why is that? Because they are in parentheses and being squared. I have to take care of that first. It's just like when we solved equations, we couldn't do something if there was a distributive property that needed to be done, right? It's the same thing here. Remember, married, single, do not mingle. So we have to get rid of this first. So before I do anything else, I'm gonna handle the top separately. I need to basically distribute this exponent. I have to use it. I have to raise the 5 to the 2nd power, the x squared to the 2nd power, and the y cubed to the 2nd power. So this is going to end up looking like 5 squared times x squared squared times y cubed squared. Okay, and that's going to all be over. Same thing in the bottom. This is going to be 10 squared times x squared times y squared. Okay, and I'm just going to rewrite this with applying all the rules. So 5 squared is 25, right? X squared squared, that's power 2 power rule. So I keep my base and multiply the exponents. So that's going to be x to the 2 times 2, which is x to the 4th. And then y, same thing, keep the base, multiply the exponents. So that's y to the 3 times 2, which is y to the 6th. Much nicer now, right? And in the bottom, I have 10 squared, which is 100. And then x squared and y squared. Okay, so now I'm going to break these up by the like terms, so to speak. So 25 over 100 times x to the 4th over x squared times y to the 6th over y squared. And now I can apply my rules here and make everything much easier. Put your 25 over 100 into your calculator if you can't see that that's a fourth, and then use math_frac. So that's 1/4 times x to the 4th divided by x squared. We keep the base and subtract the exponents. So 4 minus 2 is 2 times, keep the base, subtract the exponents. 6 minus 2 is 4. So as a final answer, this is going to be just, you would just write it without the dots. 1/4 x squared y to the 4th. Voila. Okay, so I would like for you to try A on your own. So pause this, give that a shot, and then unpause to check. Okay, did you get 3x squared? Hopefully you did. Just to quickly explain, before you begin breaking anything up, you have to apply this exponent to the whole term here, right? So we're doing basically like the distributive property, 3 raised to the 3rd power and the x squared raised to the 3rd power separately. So 3 to the 3rd power is 27, and then x squared to the third power, keep the base, multiply the exponents, x to the sixth. The 9x to the fourth stays the same. Then we break it up by the like term, so it's 27 over 9, and x to the sixth divided by x to the fourth. And then 27 over 9 is equal to 3, and then we keep the base and subtract the exponents. So I get 3x squared. Okay guys, I know this looks crazy, but if you follow my steps and you go slowly and you write everything out and be nice and detailed, you will be fine, I promise. Okay? Have fun with this. If you like algebra, this is the kind of thing that you'll like. All right, good luck.